we will begin with the January 2011 regions. In the first question, and you can download this file, I put the file out there which is downloadable so that you can work it all out, and then we can go through it together. So go through that first. In the first question, be careful about the first one because it says to you which one does not represent, and I just lost it, give me 1 second. Which one does not represent a function? Now, in those not words, be really careful again because you want to make sure you just don't look at the first one. A function says it passes a vertical line test. So therefore, you want the one that does not pass a vertical line test. They love this type of question. This question, a one-to-one function and an onto function, know those definitions. So which one does not pass is this one. If we drew a vertical line through it, it would intersect it at 2 places. So your choice here was number 4. Okay. In the next one, it talks about the roots of the equation. They want to know, are they imaginary? Are they real and rational? Are they real, rational, and equal? Then this one would bounce off the axis. Now, you can graph this in your y equals and take a look at your roots. When you graph this, you can even use the fact, does it bounce off? Does it, whatever it happens to be doing? You're going to find that if it bounces off the x-axis, comes through that x-axis, then it's going to look like this. It's only going to touch this once at that x-axis. You can also use your discriminant. Okay, here's your discriminant. This actually is part of the quadratic that fits underneath that radical. You have negative b plus or minus, go all over 2a. All you care about is what's underneath this radical. So identify a as 1, b as negative 10, and c as 25. And plug this piece in here. So you're going to end up with negative 10. Remember to put parentheses if you square a negative, or just don't put the negative sign there, times 1 times 25. Now, I like to put the radical there. Just put this piece in your calculator, and you do come out with a 0. Now, when you take the square root of 0, it is 0. That's what gives you the equal part of this. If this was negative, you'd have imaginary. If this was radical 9, you'd have rational roots. If it was radical 10, you would have irrational roots. Okay, number 3 tells us which of the values of x are solutions of this equation. Now, you can always plug them in. Plug in x is equal to 0, x is equal to 1, x is equal to 2. Now, they all contain 0, so I would not try 0. I would start with x is 1 and eliminate the 3 and 4 if x equals 1 works. And if it doesn't work, then you're here at the 3 and 4 and try one of those. So make it as easy as possible. You could graph it. You could put this in your y equals and graph it and look for where y is equal to 0. Look in your table for where y is equal to 0 and see where these guys are. That's another way to do it. Or you could solve this, and we would have to factor this. Take out your greatest common factor. Each one of these contains an x. Then factor it again. Don't forget to bring this guy down. This factors into 2 binomials. One's a plus, one's a negative, so that when I multiply, I get a negative. And factors of 2 are 1 and 2. The 2 has to be positive, and the 1 because you want your remainder to be positive. Then set these factors equal to 0. And here's your answers. There's a number of ways to do that. I would suggest working them out and then checking them on your calculator. Number 4, this is your unit circle. Whenever you have your unit circle, remember that your radius is 1. So right away, I would plug my radius to 1. Make your triangle so that it forms a bow tie against the x-axis. Everything goes up and down to the x-axis like a bow tie. This is your x, this is your y. So your x in this case is negative radical 2 over 2. Your y, negative radical 2 over 2. If you recognize this, this guy happens to be a 45-degree angle. You need to know those special right triangles. We know that as 1 radical 2 and sine and cosine are both 1 over radical 2, which when we rationalize it, gives us radical 2 over 2. That tells you that this reference angle is 45. The complete angle from here to here is 180 plus 45, which gives you 225. Now, you can also take the choices and put in, they want to know what angle this is. If you remember that the x is the cosine, the y is the sine, and in this case they happen to be both the same, you can say, what is the sine of 45? That's going to be a positive 0.707. Not happening. These guys are negatives. I can put in the sine of 135. That'll give me a positive. Well, I got negatives. Sine of 225. Now I get my negative. And this is in quadrant 3 because it goes from 180 to 270. Make sense out of your diagrams. Okay? Okay, here's a sequence one. Now they want to know which one is the 15th term of this sequence. Now first you have to determine, is this a geometric metric where I multiply something, or an arithmetic when I'm adding something? So start like this. Can I add something to get from 5 to negative 10? And then add the same thing on down, and on down, and on down. Or can I multiply something? So in this case, if I subtract a negative 15, subtract a negative 15, that's not working because your signs are changing every other one. So you know you must be multiplying by a negative to make your signs change. And from here to here, I'm multiplying by a negative 2. So you have a geometric sequence. Now, you have to know this formula. It'll give you the sum formula, but you have to remember this one. Maybe write it down on your formula sheet for yourself so that you remember it, and you can plug them in. If I'm looking for my 15th term, I need my first one, which I have as 5. I need my ratio, which I know is negative 2, and I'm 15 minus 1. Now, you can plug this into your calculator, and you will find your 15th term. If you don't remember this formula, they've already given you 1, 2, 3, 4, 5. You need 5 more. Just keep multiplying them by negative 2. Multiply this last guy by negative 2. Then keep multiplying by negative 2. You're going to find it when you get to here that that's this one. That's really probably a lot less work if you're just answering one of these problems. Number 6 is an absolute value. Absolute value, whenever you start an equation, remember to isolate the absolute value, which means you have to get it on one side by itself. So add 4a to both sides before you even start. Now, in your absolute value, let's take a small one. X can either be a positive 3 or X can be a negative 3. You have a positive and a negative root. So you're going to send this guy to your positive, take it out of the absolute value, and set it equal to whatever it says it is, solve. And then your negative root, take it out of the absolute value, and set it equal to the negative. But be careful, this has two terms. So distribute your negative sign. And then you're going to solve for A in both situations. Now, when you solve for A in this one, A is equal to 1/2. When you solve for A in this one, A is equal to actually, your A's are going to eliminate. If you subtract 4A, your A's will eliminate, and you will be this, which is not true. So this one has no solution on this side. Now, if you check the 1/2, you can see it's here. But if you check it inside, and you should always check your absolute value equations, this one does not work. So we have to reject this one. It's an extraneous root, and therefore we have no solution. No solution is the null set, not 0. On number 7. Number 7 is a double angle formula. You have all your definitions of your double angle formulas in the back. We have the sine of 2A is equal to 2 sine A cosine A. That comes from your sheet in the back. They give you that this resides in quadrant 1, and your sine is y over r. You can find x by Pythagorean's theorem. Find the x. And x is going to be radical 5. So therefore your cosine of A is radical 5 over 3. You're going to substitute it into both of these. I need the 2. My sine, remove this, and substitute in 2/3. I have my cosine, remove this, and substitute in radical 5 over 3. Remember, you're going to have to do this by hand. You can't put this in your calculator unless you go back and you check all those answers. Multiply the tops, and you'll get your answer. Now, should you put that in your calculator, then put all the choices in your calculator until you get the same irrational answer. Okay, number 8 is a dartboard. Or maybe not. Number 8 is a dartboard, which makes it a circle. This circle has 2 lines that intersect at the center, and therefore you know it makes vertical angles. Those 2 are congruent, and these 2 are congruent. Vertical angles. This central angle in sector 2, that's this one in sector 2, measures 2 pi over 3. So does its opposite one. Now, you have a number of ways you can do this. You need to find out what these are equal to, 1 and 3. Half of your circle, if you work in radians, is pi, is 180. Since your denominator is 3, then this is also equal to 3 pi over 3. If I take 3 pi over 3 and I subtract 2 pi over 3, I get 1 pi over 3. That's this angle. If you put this in terms of degrees, this is 120 degrees, this is 60 degrees. That's doable as well. And then so is this one. Now you have to remember that you have to have all equal sections. So therefore, this is divided equally. So now you have 6 sections to this. What is the probability that it will land in sector 1 or 3? These are only 2 sectors out of 6. We didn't even have to find the angles. We just had to figure that they were exactly half. And by doing this, we could see that this was a 60 and this is a 120, so that you knew that they were all divided equally. And so therefore that reduces to your 1/3. Number 9, it's a composition of functions. Remember, with your composition of functions, you start at the right and you roll it into the left. So start with f of x. Under it, you write your g of x. And remember to take this entire f of x and replace that x. And then distribute. And check to see, maybe they didn't distribute, but make sure you check and see if they did. So there's your answer 2. If they put a number in it, then you're putting a number into one and putting the result into the next one. Number 10 is another sequence. They want a common difference of 4. This has to be an arithmetic sequence. So it's something you're adding, not multiplying. You can see here, from 0 to 4n, it's not working. From n to here, you're multiplying by 4. So both of these are not helping us. Now, take n plus 1, and add 4. And take n plus 5 and add 4. Do you see your sequence? They're adding 4. This one here is not adding 4 to that. It's multiplying that 4, but we can't do it that way. So there's your arithmetic sequence for your 10. Okay, conjugates. Conjugates, remember that definition. They are the same terms, but the sign in the middle is the opposite. So I'm going to get 7 plus 5i. That's a very nice 2-point problem, and we have seen that in quite a few regions. Excuse me. Number 12, this is your arc sign. Sign the inverse. This tells me I have an angle whose sine is 5/8. I want to know what angle is that. Now, all they're asking you to do is actually just to turn it around into a regular sine function. So we don't want your cosine, and we can't flip these around. Your cosine cannot be greater than 1, and your sine cannot be greater than 1. So all it's asking you for is this, is just to rewrite this. I have an angle whose sine is, so if my angle is A, the sine of A is equal to 5/8. That's all they wanted for that one. It was actually more confusing than that. How many distinct triangles? They pretty much like this. This is your ambiguous case of sine. Sine is the only one has an ambiguous case because sine is positive in quadrant 1 and positive in quadrant 2. So sometimes when you use your law of sines, you can find another angle for it. So in this case, if we label this, and we look for your sine, we label A over sine of A, B over sine of B. Find these, just plug them in. Remember, when you cross multiply, you're actually finding a sine of B. Your angle could exist in 1 or 2. So take its inverse, do the second sine, and find me an angle whose sine is this. This angle is 48 degrees. That sits right here in quadrant 1. That's your reference angle also for quadrant 2. So if I could say angle 1 could be 48 degrees, this angle could be 180 minus 48 degrees, would be 132. Then the next key is take the existing one. This would be angle B here. So if I add 35 to this one, I'm going to get 167. I can still have another angle before I hit 180. And this one, of course, if I add this to my 35, I can still be able to subtract it from 180. So in this case, you have two possible angles. If this guy had been a little higher, let's say it was 152, and I added 152 and 35, if I am over 180, there cannot be a third angle. That wouldn't have worked. Okay. Number 14, be careful of number 14. The problem is the wording. This piece is subtracted from this piece. 3 is subtracted from 5. You say 5 minus 3. So you take this one and you subtract the entire piece. Now, they did set it up nicely so that your denominators would work. Just remember that it's this whole thing. So you have to distribute your negative sign. Distribute your negative sign. This negative becomes a positive. This negative becomes a positive. And group. You have the same denominator, so you're subtracting your numerators. This would give you 2 over 2, or 1 x squared. Okay. Then do your x's. Negative 3/4 plus 1/4 would give you negative 2/4. And notice they just reduced it to negative 1/2. And the last one, 1 plus 4, gives you 5. So you're looking at choice 2. Here's an inequality. Now be careful of your inequalities. Pull everything to one side. It's a quadratic inequality. You want to know where it's greater than 0, and on your number line, anything greater than 0 is positive. So you want to know where it's positive. So the first step is to find your critical values. Factor this. So your critical values are at 5 and negative 2. Put that on a number line. Because this is a greater than and not a greater than or equal to, these are both open. Now, you can do it the old-fashioned way. Just go in and test. Put this in your y1 and test. Take a value to the left of negative 2. So say you look for x is negative 3. Find out if your y is positive or negative. In this case, it would be positive. Take a value between here. Take x is 0. This has a negative y. Take a value here. Look at x is 6. It has a positive y. You want the positives, so you have an or statement. Now you can also superimpose your parabola over here, where you can see the negatives and you can see the positives. So you've got an or statement. You can get rid of your and statements. And your or would be here at number 3.